From the first moment our eyes turned upward, the sky has been our greatest mystery. It has been a canvas for myth, a clock for farmers, a compass for travellers, and a stage for gods. But with the invention of telescopes, the sky became something more. It became knowable. Glass and mirror, light and shadow, turned wonder into vision, and vision into discovery. With each generation, telescopes carried us farther, from the craters of the moon to the faint light of galaxies billions of years away. They have shown us not only what lies above, but who we are below, small, fragile, and yet capable of building eyes powerful enough to see creation itself. This is the story of telescopes, our cosmic eyes, the instruments that transformed imagination into knowledge and silence into song. Before telescopes, the sky was already a stage of wonder. Ancient people looked upward and saw order in the chaos of stars, patterns that became myths, calendars, and maps. The night sky was their scripture, their clock, their compass. With no cities yet to drown starlight, the heavens were vast and immediate, stretching endlessly overhead. Every culture responded with awe, building traditions around the movements of celestial lights. In these early days, human beings had only their eyes to explore the cosmos, but even then, vision was already our first telescope. The earliest sky watchers tracked the sun and moon with careful precision. In stone circles like Stonehenge or Newgrange, great blocks aligned with solstices and equinoxes marking the seasons. Farmers needed to know when to plant, sailors needed to know when to set sail, priests needed to know when to worship. The sky was both practical and divine. Watching it was survival, but also reverence. The night sky was not silent to them. It spoke in patterns, rhythms, cycles. They built monuments that were themselves instruments, great fixed telescopes of earth and stone, designed to mark the rising of the sun or the appearance of particular stars. In Mesopotamia, priests recorded the motions of planets on clay tablets, noticing patterns that repeated over years and centuries. The Babylonians turned astronomy into mathematics, predicting eclipses, mapping paths, seeing order where others saw chance. In China, court astronomers tracked comets and novae, considering them signs of fate. The Mayans built observatories with windows aligned to Venus, weaving astronomy into religion and politics alike. Each culture gazed upward, not with lenses of glass, but with lenses of imagination and patience. For most of human history, the naked eye was enough. The Milky Way stretched like a river of light across the sky, an unbroken mystery of countless stars. Planets moved among the fixed stars, their wandering unsettling and mysterious. The moon waxed and waned, reliable and rhythmic. With only their eyes, ancient astronomers catalogued hundreds of stars, divided the sky into constellations, and imagined stories that would survive thousands of years. Sound and memory preserved what sight discovered. But naked eyes had limits. The stars were countless, yet still too few. The surface of the moon looked smooth. The planets were only wandering lights. The Milky Way was a blur. Humanity sensed there was more to see, but no tool yet existed to extend vision beyond flesh. The cosmos remained at once intimate and unknowable. The story began to change in the late Renaissance, when lenses crafted for spectacles revealed new possibilities. Artisans grinding glass for reading soon discovered that lenses could magnify. Children played with crude spyglasses, nobles commissioned devices to watch ships at sea. The idea of extending sight with glass was no longer fantasy but craft. Though not yet pointed at the heavens, the seeds of telescopic vision were sown. When people first turned these early lenses upward, the sky transformed. What had seemed distant became near. The moon, once a glowing disk, revealed mountains and valleys. The stars, once countable, multiplied beyond imagination. Planets revealed shapes and companions, mysteries that had been invisible for millennia. Humanity had, in an instant, extended its eyes into the cosmos. This was not just a technical change, it was a philosophical earthquake. For centuries the heavens had been thought perfect, unchanging, divine. The earth was at the centre, the stars fixed in crystalline spheres. But through glass this illusion cracked. The moon looked scarred and imperfect, like Earth itself. Jupiter had moons circling it, tiny lights orbiting a planet that was not Earth. The universe was no longer a neat hierarchy but a dynamic system, vast and shifting. The telescope had not only extended human sight, it had shaken human certainty. The first telescopes were small, fragile, crude, yet they revealed truths too great to ignore. Galileo's sketches of lunar craters, sunspots, and Jupiter's moons were as radical as any revolution. They said, "Look closer, and the world is not what you believed. Look deeper, and the universe is stranger than you imagined." The eye alone was no longer enough. The telescope became the new organ of vision, the true eye of humanity. From that moment onward, the cosmos was never again simply the stars seen from Earth. It became detail, depth, discovery. What had once been symbols for gods became places. What had once been myths became matter. The telescope transformed wonder into knowledge, and knowledge into further wonder. This was the dawn of cosmic vision, not just the invention of an instrument, but the beginning of a new way of being human. For the first time, we were no longer confined to the range of our bodies. Our sight leapt beyond itself, through glass and into the heavens. We became more than creatures of Earth. We became witnesses of the universe. When Galileo Galilei lifted a small telescope toward the heavens in 1609, he could not have known that he was about to change humanity's place in the universe forever. The device he held was crude, no more than a tube with ground-glass lenses, barely magnifying beyond what the naked eye could see. And yet, through it, the sky transformed. That moment was not just the improvement of vision. It was a revolution of thought, the beginning of astronomy as we know it. Galileo was not the first to build a telescope. The earliest spyglasses appeared in the Netherlands, fashioned by spectacle makers who realized that combining lenses could magnify distant objects. Merchants used them to watch ships at sea, generals to observe battlefields. These were tools of commerce and war, not of philosophy. But when word of them spread to Italy, Galileo refined the design, increasing its magnification, and crucially he turned it upward. Others saw in the telescope a tool for Earth. Galileo saw in it a new eye for the heavens. What he found astonished him. The moon, once a perfect silver disk, revealed mountains, craters, and shadows. It was a world rough and scarred, not the flawless sphere imagined by philosophers for centuries. The heavens, once thought divine and unchanging, bore the same marks of imperfection as Earth itself. Turning his telescope to Jupiter, Galileo discovered tiny points of light circling the planet. Night after night, he watched them shift, sometimes on one side, sometimes on the other. They were moons, orbiting Jupiter as Earth's moon orbited us. The Ptolemaic model with Earth at the unmoving centre could no longer hold. The cosmos was not built around us. The heavens had their own centres, their own systems. Saturn baffled him. Through his small lens, it appeared not as a planet alone, but with strange ears at its sides. His telescope was too weak to show the rings clearly, but he saw enough to know Saturn was not a simple sphere. Venus, too, revealed secrets. It showed phases like the moon, growing from crescent to full. This was proof that Venus orbited the Sun, not Earth. Each discovery struck blows against the old worldview, each observation widening the crack in centuries of certainty. Galileo's telescope did not only reveal new objects, it revealed a new method of knowing. Truth was no longer handed down by ancient authority. It was visible, through glass, to anyone willing to look. The telescope democratized the cosmos. It said, "Do not believe because someone tells you. Believe because you can see it yourself." But vision came with danger. The Church had long upheld an earth-centered cosmos as divine truth. To suggest otherwise was heresy. Galileo's findings supported the Copernican system, where the Sun, not Earth, was central. His writings spread, challenging doctrine. For this, he was tried, silenced, confined. Yet even as he suffered, his telescope had already spoken. The heavens were no longer closed. The truth was visible, undeniable. The impact rippled outward. Telescopes spread across Europe, each improvement sharpening. Vision. Astronomers discovered that the Milky Way, once a faint band of light, was composed of countless stars. They mapped sunspots, revealing the sun's restless surface. They studied comets, showing them to be celestial wanderers, not omens of doom. The universe expanded with every lens. By the 17th century, telescopes grew in size and power. Isaac Newton built a reflecting telescope, replacing lenses with mirrors to reduce distortion. This design allowed for greater clarity and remains the foundation of many telescopes today. With each refinement, the eye of humanity extended farther, reaching beyond planets to nebulae, beyond stars to galaxies. The telescope became more than an instrument. It became a symbol of our hunger to see, to know, to reach. The philosophical shift was profound. For millennia, the sky had been myth, mystery, metaphor. Now it was a place, physical, measurable, imperfect, infinite. Humanity was no longer at the center, but adrift in a vast cosmos. This was not despair, but liberation. To see more was to be more, to understand that we were small but capable of great vision. Galileo's telescope was only a tube of wood and glass, fragile and simple, but in it lay the seed of modern astronomy, of cosmic humility, of scientific method. It proved that with tools we could extend our senses, break the boundaries of flesh, and glimpse truths hidden for eons. It proved that the universe is not what it seems until we dare to look closer. From that night in 1609, humanity's eyes were forever changed. The telescope had transformed us from watchers of the sky into explorers of the universe. What began as a spyglass became a cosmic eye, and through it, the stars ceased to be distant lights. They became worlds, systems, galaxies, mysteries unending. This was the true dawn of telescopic vision. Not just the invention of an instrument, but the awakening of a species to its place in the cosmos. The telescope had opened the heavens, but its earliest forms were still crude, limited by the imperfection of lenses. As the 17th century unfolded, the question became not whether telescopes could reveal the cosmos, but how far they could reach. Humanity had discovered a window into the sky. Now it sought to make that window larger, clearer, sharper, an endless pursuit of light. The simplest design was the refracting telescope, which used curved glass lenses to bend light and bring distant objects into focus. These were the instruments Galileo and his successors had used. At first they seemed miraculous, but soon their flaws became apparent. Lenses distorted colours, producing halos around bright objects. Long tubes were required to gather enough light, some stretching to absurd lengths, 40, 60, even 100 feet. Astronomers built them in fields, mounting them on wooden frames so vast they could barely be aimed. These giants were impressive but impractical, monuments to ambition more than tools of discovery. And yet, refractors had their triumphs. With them, astronomers charted the moons of Saturn, observed the shadows of Jupiter's satellites crossing its face, and refined measurements of planetary orbits. The clarity was greater than the naked eye could ever achieve. But the dream of a perfect refractor faded as its flaws grew undeniable. Lenses could only grow so large before sagging under their own weight, distorting the image they were meant to clarify. The quest for vision demanded a new design. That design came from Isaac Newton. Instead of lenses, Newton turned to mirrors. A reflecting telescope used a curved mirror to gather light and reflect it to a focus. Mirrors had advantages. They did not produce colour fringes, and they could be supported from behind, allowing them to grow larger without sagging. Newton's small reflector, built in 1668, was humble compared to the giant refractors, but it pointed the way forward. In time, reflectors would dominate astronomy, enabling discoveries on scales refractors could never reach. Still, refractors were not abandoned. Craftsmen improved lens making, creating achromatic lenses that reduced colour distortion. Throughout the 18th and 19th centuries, refracting telescopes grew into elegant instruments housed in domed observatories. Their long gleaming tubes became symbols of science itself, monuments of glass and steel dedicated to vision. Some of the largest refractors still stand today, beautiful relics of an age when glass was king. But beyond their mechanics, telescopes became cultural symbols. Observatories rose on hilltops, their domes turning slowly in the night like mechanical eyes. Cities and nations funded them, proud of their ability to pierce the heavens. Astronomers, once lone scholars, became professionals, working in institutions dedicated solely to seeing farther. Telescopes were not just tools. They were monuments of ambition, embodiments of the belief that the universe was knowable if only one could look clearly enough. The drive to improve telescopes revealed something profound about humanity itself. We were no longer content with myths or even with first glimpses. We wanted detail. We wanted precision. We wanted to know not just that Jupiter had moons, but how they moved. Not just that Saturn was strange, but what shaped its form. Not just that the Milky Way was filled with stars, but how many, how distant, how vast. The telescope became a ladder of curiosity, each rung leading higher, each view leading to the next question. But even as telescopes advanced, they remained bound by Earth. The air itself was an obstacle, turbulent, shifting, blurring the stars. No matter how perfect the lens or mirror, the atmosphere smeared the light. Stars twinkled not because they burned that way, but because air made them dance. The dream of perfect vision was always just out of reach. Still, astronomers pressed forward, building larger, more refined instruments, striving to make windows of light clearer with each generation. This was the age when telescopes became not curiosities but institutions. Observatories rose across Europe and America, domes sheltering great refractors that turned slowly toward the sky. These were temples of light, dedicated to a new kind of worship, the worship of knowledge, of vision, of discovery. For those who gazed through them, the heavens were no longer myths or mysteries. They were realities, waiting patiently to be seen. The window had been opened. Humanity would not close it. By the 18th and 19th centuries, telescopes had grown far beyond the fragile tubes of Galileo's time. They were no longer small instruments held by hand, but towering machines housed in buildings designed specifically to serve them. The observatory became a new kind of architecture, part temple, part machine, part cosmic eye gazing outward. The earliest observatories were modest, towers with slits in the roof, platforms where astronomers could set up their instruments. But as telescopes grew in size, so too did the structures around them. Domes rose on hilltops, their curved shells rotating smoothly to follow the stars. Within them, long tubes of brass and steel stretched upward, mounted on heavy supports, turning with careful precision. The observatory became not just a tool, but a landmark, a symbol of a society investing in the pursuit of knowledge. These buildings were often placed far from cities, high above plains, where air was thinner and skies clearer. In Europe, great refractors were installed in Paris, Vienna, and Berlin. In America, institutions like the Lick Observatory in California and Yerkes Observatory in Wisconsin became monuments to scientific ambition. Their telescopes were enormous refractors, their domes majestic against the horizon. Visitors flocked to see them, even if they could not peer through the eyepiece. The observatory itself became a cultural statement. Here was a community that looked to the heavens. Inside, the work was painstaking. Astronomers climbed ladders to reach eyepieces mounted high above the ground. They charted stars by hand, making careful sketches or recording measurements with delicate instruments. Photographic plates later replaced sketches, allowing telescopes to preserve what the human eye could see. Hours of exposure captured faint details, building images that revealed the invisible. Where the eye saw a faint smudge, the plate revealed galaxies, nebulae, and star clusters in astonishing richness. The telescope had grown beyond vision. It had become a recorder of cosmic history. These observatories were more than scientific tools. They were cultural icons. Visitors described them as cathedrals of light, their domes opening like holy doors to the sky. At night, the machinery hummed softly as telescopes swung into position, following stars across the dome. The astronomer at the eyepiece was a kind of priest, interpreting the heavens for humanity below. The metaphor was not accidental. Just as temples once aligned with the rising sun or the solstices, observatories aligned with the eternal dance of stars. They were our modern sacred spaces, not of worship, but of wonder. But as magnificent as they were, ground-based observatories still wrestled with limitations. The Earth's atmosphere blurred images no matter how high the telescope was placed. Air currents distorted starlight, bending it into shimmering twinkles. Light pollution from growing cities further dimmed the view. Astronomers knew that beyond the atmosphere the stars shone steady, undisturbed. The dream of leaving Earth behind and placing telescopes in space began to stir long before it was possible. Yet even with these flaws, 19th and early 20th century observatories transformed our vision. They revealed the spiral structure of galaxies, catalogued thousands of stars, and discovered the expansion of the universe. They showed that the Milky Way was not alone, but one among countless galaxies stretching into infinity. The observatory dome, with its great eye turning through the night, became a symbol of humanity's awakening to the immensity of the cosmos. Each telescope built on the last, each observatory extended the reach of human sight. They were windows of light in both senses. They gathered photons from across the universe, and they illuminated the human mind. To look through them was to realize that the cosmos was far larger, far stranger, and far more beautiful than anyone had imagined. The telescope had begun as a simple tube of glass and wood. Now it was a monument of steel and stone, a cathedral dedicated to vision. And still, the window was not wide enough. Humanity was ready to look beyond visible light, beyond Earth, beyond imagination itself. For centuries, telescopes were tied to one truth. They showed only what the human eye could see. They gathered visible light, the narrow band of wavelengths that slip through our atmosphere and paint the sky blue, the sunsets red, and the stars white against black. But the cosmos is not limited to this tiny sliver of the spectrum. Light comes in many forms, invisible to our eyes yet filled with information. The great leap of the 20th century was realizing that the universe speaks not only in visible light, but in an entire symphony of radiation, and to hear it, telescopes had to evolve. The first step came with radio. In the 1930s, Karl Jansky, an engineer working for Bell Telephone Laboratories, was studying static on telephone lines. He built a rotating antenna to trace sources of interference. To his surprise, he discovered a hiss that came not from storms or equipment, but from the sky itself. Night after night the signal returned, strongest when his antenna pointed toward the constellation Sagittarius. Jansky had stumbled upon radio waves from the centre of our galaxy. The universe was speaking in a frequency no one had thought to listen to before. Jansky's discovery went largely unnoticed at first, but others took interest. Grote Reber, a radio enthusiast in Illinois, built a parabolic dish in his backyard in 1937. The first purpose-built radio telescope. While optical astronomers pointed refractors and reflectors at the heavens, Reber listened. His dish revealed that the sky was alive with radio signals, emissions from the sun, from stars, from distant galaxies. Where the optical eye saw darkness, the radio ear heard noise. The invisible universe was beginning to speak. After World War II, radio astronomy flourished. Military radar technology found new purpose in listening to the sky. Dishes grew larger, scattered across landscapes, tilting slowly as they followed invisible signals. They revealed phenomena never seen through glass, pulsars, neutron stars spinning with lighthouse beams of radio waves, quasars, distant, powerful sources so bright in radio they outshone entire galaxies, and the faint afterglow of the Big Bang itself, the cosmic microwave background, the oldest light in the universe. Radio telescopes transformed astronomy. They were not limited by clouds or daylight. They could see through dust that obscured galaxies in visible light. They revealed structure, motion, and energy invisible to eyes or lenses. Humanity had opened not just a window, but an entirely new sense, like gaining ears after millennia of relying only on sight. But radio telescopes did more than expand knowledge. They expanded imagination. For the first time, astronomers could map the spiral arms of our own galaxy, tracing their shape with signals from hydrogen atoms. They discovered black holes not by seeing them, but by detecting their powerful emissions. They listened to the whispers of the cosmos and realized that the silence of the night sky was an illusion. The universe was alive with chatter, waiting for us to tune in. The scale of radio telescopes grew to match their ambition. The Arecibo Observatory in Puerto Rico, built in the 1960s, was a giant dish 300 meters wide carved into a natural sinkhole. It listened to pulsars, tracked asteroids, and even broadcast humanity's first intentional message to the stars. It became a cultural icon, appearing in films and novels, symbolizing humanity's attempt to listen to the universe. Elsewhere, arrays of smaller dishes linked together, creating virtual telescopes the size of continents. By combining signals through interferometry, they achieved resolutions optical telescopes could never dream of. radio astronomy became not just listening but high-definition vision in frequencies beyond sight. The discovery of pulsars in 1967 by Jocelyn Bell Burnell was among the most dramatic. At first, the regular signals seemed so precise, so artificial, that they were jokingly labelled LGM, little green men. But they were natural, collapsed stars dense beyond imagination, rotating rapidly and beaming radio pulses across the cosmos. These signals revealed extreme physics, objects so compact they defied ordinary understanding. Without radio telescopes, they would have remained forever hidden. Through radio, humanity realized that the universe was not silent, not static, not serene. It was dynamic, violent, filled with energy invisible to our eyes. Telescopes had evolved from glass lenses to giant dishes, from capturing light to capturing signals. The cosmos was no longer only what we could see. It was what we could hear in frequencies far beyond vision, and this was only the beginning. Beyond radio lay infrared, ultraviolet, X-rays, and gamma rays, entire worlds of light waiting to be explored. The telescope was no longer just an eye. It was becoming an entire spectrum of senses, extending human perception into the fullness of the universe. Radio telescopes had opened humanity's ears to the cosmos, but they were only the beginning. Beyond radio waves lies a vast spectrum of invisible light, infrared, ultraviolet, X-rays and gamma rays, each carrying its own story of the universe. Our eyes see only a narrow band of wavelengths, but the cosmos shines in many colours we cannot perceive. To reveal them, astronomers built new telescopes, instruments not of glass and mirrors alone, but of sensors and detectors tuned to the hidden symphony of radiation. Infrared light was the next great frontier. It lies just beyond red on the spectrum, too long in wavelength for human eyes to detect. We feel it as warmth on our skin, the heat radiated from fires, bodies and stars. For centuries it was invisible, until William Herschel discovered it in 1800 while experimenting with sunlight and prisms. By placing a thermometer just beyond the visible red band, he noticed a rise in temperature, evidence of invisible rays carrying heat. This discovery hinted that the universe contained secrets hidden in warmth itself. Infrared telescopes allow us to see what is cloaked in dust. In visible light, star-forming regions are obscured by dark clouds, but in infrared, the dust becomes transparent, revealing newborn stars still cradled in cosmic wombs. Galaxies once hidden emerge glowing in infrared, their energy radiating in long, gentle waves. Whole populations of stars too cool to shine brightly in visible light become clear. The universe, once thought dark, reveals itself as alive with warmth. Yet observing in infrared from Earth is difficult. Our own atmosphere glows in infrared, swamping signals from space. Water vapor especially blocks much of this radiation. Astronomers built infrared observatories on high mountaintops and dry deserts, but even these were not enough. The true revolution came with space-based telescopes, satellites that floated above the atmosphere, free to see the invisible. Missions like the Infrared Astronomical Satellite, IRAS, in 1983, Spitzer in 2003, and most recently the James Webb Space Telescope, have turned infrared into one of the most powerful tools of modern astronomy. They reveal the earliest galaxies, formed only hundreds of millions of years after the Big Bang, their faint warmth stretched across billions of years of cosmic expansion. Through infrared, we look not only into hidden places but into deep time. Beyond infrared lies ultraviolet, the light just beyond violet, too short in wavelength for human eyes. We know its presence on Earth through sunburn, as UV rays stream from our star. In space, ultraviolet reveals young, hot stars blazing at temperatures thousands of degrees higher than the Sun. Galaxies teem with ultraviolet light where star formation runs wild. Supernova remnants glow fiercely, their expanding shells of gas ionized and burning. Without ultraviolet telescopes, this energetic side of the universe would remain unseen. Satellites like the Hubble Space Telescope have captured this spectrum, showing galaxies and nebulae in colours invisible to the naked eye, painting a universe of youth and energy. Then come X-rays, waves so short and powerful they pass through flesh, used in hospitals to image bones. In the universe, X-rays come from extremes, black holes devouring matter, neutron stars colliding, galaxies filled with hot gas. These are places of violence, where gravity crushes and heat soars to millions of degrees. From Earth, we cannot see them. The atmosphere blocks X-rays, protecting life but blinding astronomers. Only with space telescopes like Chandra and XMM Newton have we glimpsed this hidden cosmos. In X-rays, the night sky is not serene but violent, littered with explosions, collisions, and blazing remnants. At the far end of the spectrum are gamma rays, the shortest, most energetic form of light. They are born in the universe's most cataclysmic events: supernovae, black hole jets, gamma ray bursts that release more energy in seconds than the sun will emit in its entire lifetime. Gamma ray telescopes like Fermi detect these bursts, revealing a universe of extremes beyond imagination. These signals are fleeting, intense, and rare, but they carry the signatures of the most powerful processes in existence. Each of these windows, infrared, ultraviolet, X-ray, gamma ray, has rewritten our view of the cosmos. Through them, we have discovered galaxies colliding, stars being born, stars dying, black holes feeding, and the faint glow of the universe's birth. They reveal that the cosmos is not simply a quiet stage of stars shining steadily, but a dynamic, violent, evolving place. The shift to multi-wavelength astronomy changed everything. No longer do we look at the sky in one colour. We see it in layers, each wavelength a new translation of reality. A single galaxy looks different in visible, infrared, ultraviolet, and X-rays. Each view is true, yet incomplete. Only together do they form the whole. The universe is a symphony, and each wavelength is an instrument. To hear only one is to miss the music. Telescopes have thus become more than eyes. They are translators, revealing dimensions of reality beyond human senses. They show us that the cosmos is richer, stranger, and more alive than vision alone could ever reveal. The visible sky is only the surface. Beyond it lies infinity. For centuries, astronomers built bigger and better telescopes on Earth. They climbed mountains, searched for the clearer skies, and polished mirrors to perfection. But no matter how advanced the instrument, one obstacle remained: the atmosphere. The same blanket of air that makes life possible also blurs and distorts starlight. To our eyes it makes stars twinkle, but to astronomers it was a curse. No lens or mirror could fully defeat the turbulence of Earth's sky. The dream became clear: to place a telescope beyond the atmosphere itself, to see the heavens without distortion, to gaze into space from space. That dream became reality in 1990 with the launch of the Hubble Space Telescope. Named after Edwin Hubble, the astronomer who discovered that the universe is expanding, it was carried into orbit by the Space Shuttle Discovery. Hubble was unlike any telescope before it, not perched on a mountaintop but floating in Earth's orbit, 560 kilometers above the surface, circling the planet every 97 minutes. It was a machine built not just to observe but to transcend, a human eye freed from the limits of air. Yet the beginning was not triumphant. Soon after its launch, scientists discovered that Hubble's main mirror had been ground with the slightest error, an imperfection of just 2 microns, thinner than a human hair. The result was disastrous. Images were blurred, the sharpness promised was lost. The world mocked the billion-dollar blunder in space. For a moment, the dream of perfect cosmic vision seemed to have failed. But Hubble's story was not one of failure. It was one of redemption. In 1993, astronauts aboard the Space Shuttle Endeavour visited Hubble on a daring repair mission. Floating in orbit, they installed corrective optics, a kind of glasses for the telescope. The fix worked. When Hubble opened its eyes again, the universe appeared in astonishing clarity. Images that once looked blurred now revealed stars crisp, galaxies sharp, nebulae glowing with intricate detail. Hubble was reborn, and with it began a golden age of discovery. From its perch above Earth, Hubble showed us the cosmos as we had never seen it. Its pictures became part of our cultural imagination. The pillars of creation, towering clouds of gas in the Eagle Nebula where stars are born, the Hubble Deep Field, a tiny patch of seemingly empty sky that, when examined, revealed thousands of distant galaxies stretching back to the dawn of time, the Sombrero Galaxy, with its brilliant dust lane glowing across the void. Each image was more than science. It was art, revelation, and history captured in photons. But Hubble did more than inspire wonder. It transformed science. It measured the rate of expansion of the universe with unprecedented precision, refining the age of the cosmos to about 13.8 billion years. It showed that nearly every galaxy harbours a supermassive black hole at its centre. It mapped the atmospheres of exoplanets, revealing their chemical signatures. It watched stars explode, galaxies collide, and comets crash into planets. Its instruments became time machines, peering farther back into cosmic history than any telescope before. Hubble's strength was not only its location, but its adaptability. Unlike most space telescopes, it was built to be serviced. Over 5 missions, astronauts upgraded its instruments, replacing cameras, gyroscopes, and computers. Each mission gave Hubble new life, extending its vision for decades. What might have been a short-lived experiment became a career spanning generations of astronomers. Culturally, Hubble became humanity's telescope. Its images were shared not just in scientific journals, but on classroom walls, magazine covers, and computer screensavers. They became symbols of exploration, reminders of how small we are and how vast the universe is. For children who saw its pictures, the cosmos became not abstract but visible, alive, reachable. The story of Hubble is one of persistence, the persistence of vision, the persistence of curiosity, the persistence of humanity to see farther. From its troubled start to its breathtaking triumphs, it redefined our cosmic perspective. With Hubble, the universe was no longer a distant mystery. It was present, detailed, luminous, and yet, even as Hubble revealed wonders, it also revealed limits. Its mirrors, though sharp, could not see in infrared with the depth needed to peer back to the very first galaxies. Its instruments, though powerful, would one day grow old. The dream of vision, once extended into space, demanded to go farther still. New telescopes would follow, building on Hubble's legacy, reaching into wavelengths and depths it could not touch. But for all that followed, Hubble will remain the icon of space-based vision, the moment humanity truly lifted its eyes above the atmosphere and looked directly into the cosmos. It was not just a telescope, it was our cosmic eye. If Hubble was our first great eye in space, then the James Webb Space Telescope became the successor that peered even deeper, even farther, even earlier into the universe's story. Hubble opened the heavens with clarity, but Webb was built to see beyond visible light, into the realm of infrared, where the faintest and oldest galaxies glow. It was not only an improvement, but a revolution, the most ambitious telescope humanity had ever attempted to build. The path to Webb was long and fraught with difficulty. First conceived in the 1990s as a successor to Hubble, its design demanded technologies that did not yet exist. Its mirror had to be enormous, far larger than any rocket could carry in one piece. Engineers designed it as a mosaic of 18 gold-coated segments, each folding inward like petals of a flower. Its sunshield had to be the size of a tennis, caught, 5 layers of reflective material stretched thin as hair to block the heat of the sun and earth so that its instruments could cool to near absolute zero. The telescope had to unfold itself in space, a mechanical ballet of hundreds of moving parts, each one vital, each one unable to be repaired once launched. Delays plagued the project, costs soared, critics wondered if it would ever fly. But in December 2021, atop a rocket in French Guiana, Webb finally launched. For weeks the world held its breath as it unfolded. Step by step, mirrors aligned, shields unfurled, instruments powered on. And then, when the first images arrived in July 2022, the wait was vindicated. The pictures stunned the world. A single deep field revealed thousands of galaxies, some so faint and far that their light had travelled for more than 13 billion years. The pillars of creation, already iconic in Hubble's vision, appeared in Webb's infrared as glowing, ghostly towers with newborn stars shining through the dust. The Carina Nebula bloomed with intricate shapes never seen before. Exoplanet atmospheres were probed with unprecedented detail, detecting water vapour, clouds, and even signs of chemistry that could hint at life. Webb had opened not just a new chapter, but an entirely new book of cosmic vision. What Webb gave us was not only sharper pictures but deeper time. Its infrared eyes could pierce through cosmic dust and stretch back to the universe's infancy, when the first galaxies formed. Hubble showed us a universe already mature. Webb shows us one just awakening. In its images, we see the faint red glow of galaxies that lived when the cosmos was only a few 100 million years old, fragile sparks in the darkness of creation. For the first time, we glimpse the universe as it was in its youth. But Webb is not alone. Other space telescopes extend our vision in different directions. Chandra studies the cosmos in X-rays, revealing violent black holes and exploding stars. Spitzer, before Webb, opened the infrared sky. Planck mapped the faint microwave background, the echo of the Big Bang itself. Together they form a symphony of sight, each tuned to a different wavelength, each contributing to the whole. Webb is the newest and grandest, but it stands among a chorus of instruments, each expanding our cosmic senses. Culturally, Webb's arrival echoed Hubble's decades earlier. Its images spread instantly across the globe, appearing in classrooms, on news broadcasts, in art and music. They reminded us that the universe is not only the domain of scientists, but of everyone. To see galaxies born billions of years ago is to feel both small and vast at once, to realize that our moment is part of something far greater. Webb's legacy is still being written. Its mission is expected to last at least a decade, perhaps longer, each year revealing discoveries we cannot yet predict. Already, it has challenged theories of galaxy formation, suggesting the early universe was brighter and more complex than expected. Already it has deepened our understanding of exoplanets, bringing us closer to the question of whether life exists beyond Earth. In time, it may provide answers to mysteries we have not yet thought to ask. The journey from Hubble to Webb marks a turning point. We no longer look only with eyes of glass or mirrors alone. We now build instruments that fold like origami, that see in invisible light, that reach across billions of years. Our telescopes are no longer simple tools. They are time machines designed to glimpse creation itself. And yet, even Webb will one day be surpassed. Plans are already drawn for the next generation. Telescopes to study habitable exoplanets in exquisite detail, to directly image Earth-like worlds, to search for signatures of life. Others will probe dark matter and dark energy, the invisible forces that shape the cosmos. Each one will extend our vision further, each one proving again that the human hunger to see has no limit. From mountaintops to orbit, from Hubble's glass to Webb's golden mirrors, telescopes have become the truest expression of our curiosity. They are cosmic eyes, always reaching outward, always striving to see more. With each step, the universe grows not smaller but larger, not simpler but richer. And with each new vision, we are reminded that to look into the cosmos is to look into ourselves. For all the glory of Hubble and Webb, Earth itself has not been abandoned as a home for telescopes. In fact, some of the largest and most powerful instruments ever built still stand firmly on the ground, their mirrors stretched wider than any spacecraft could carry, their domes towering over mountain peaks like cathedrals of glass and steel. Though the atmosphere continues to blur and distort, engineers have found ways to tame it, to bend its turbulence back into clarity. The result is a new golden age of ground-based astronomy, where telescopes on Earth rival even their cousins in orbit. The principle is simple. The bigger the mirror, the more light it gathers and the farther it can see. For centuries, astronomers dreamed of mirrors many meters wide, but the challenge was weight. A single slab of glass sags under its own mass, warping the image it reflects. The solution came with segmented mirrors, a mosaic of smaller pieces working as one. Each segment can be adjusted by tiny motors, aligning perfectly to form a vast surface that gathers light across unimaginable distances. Modern giants like the Keck Observatory in Hawaii pioneered this design. Each of its twin telescopes boasts a 10-meter mirror, made of 36 hexagonal segments, moving in harmony. Together they have revealed exoplanets orbiting distant stars, measured the motions of stars around the black hole at the center of the Milky Way, and mapped galaxies at the edge of the observable universe. The segmented mirror changed what was possible, opening scales of vision once thought impossible from the ground. But size alone was not enough. The atmosphere still shimmered, turning stars into blurs. To fight this, astronomers developed adaptive optics, a technology as elegant as it is complex. By shining lasers into the sky, telescopes create artificial stars. They watch how these stars twinkle, measure the distortions caused by air, and then bend their mirrors in real time to cancel the blur. Thousands of adjustments per second turn turbulence into sharpness, restoring clarity once thought lost forever. A telescope equipped with adaptive optics can see details sharper than Hubble itself, all from beneath the same sky. These instruments are not only feats of engineering but monuments of human will. The Very Large Telescope in Chile, a complex of 4 giant mirrors, works both alone and in concert, linking its light to act as one. From the Atacama Desert, one of the driest places on Earth, it peers into the universe with unmatched precision. The location is no accident. Astronomers seek the clearest skies, places high, dry, and far from city lights. Mountain summits in Hawaii, Chile, and the Canary Islands have become the homes of our greatest eyes, places where Earth itself seems to stretch toward the stars. Yet even greater telescopes are on the horizon. The giant Magellan Telescope, under construction in Chile, will combine 7 enormous mirrors to form a surface 24 meters across. The extremely large telescope, also in Chile, will stretch to 39 meters, its dome larger than a football field. These are not just telescopes, they are Earth's answer to Webb, ground-based instruments that promise to peer as far and as deeply, rivaling space observatories with sheer scale and adaptive technology. Standing before such telescopes is a humbling experience. Their domes rise like mountains carved by human hands, their mirrors gleam like pools of frozen starlight. Inside, motors hum softly, computers guide smoothly, and instruments wait patiently for photons that have travelled billions of years. Each night, when domes slide open and mirrors tilt toward the heavens, these machines become living creatures, breathing starlight, turning it into knowledge. These are our modern observatories, machines of precision, towers of ambition, and symbols of an unbroken quest. They remind us that while space telescopes soar above, Earth remains a worthy platform, its peaks and deserts hosting eyes as powerful as any ever made. With them, we continue the tradition begun with Galileo, not content to see only what the eye can perceive, but determined to see everything the universe allows. The story of ground-based telescopes today is not one of decline but resurgence, a proof that Earth is still a stage for cosmic vision. With each night's work, they remind us, the universe is vast and we will not stop looking. If a single giant mirror can open the universe, what happens when many telescopes work together? The answer has reshaped astronomy, collaboration. In the 20th and 21st centuries, astronomers realized that linking telescopes across mountains, deserts, even continents, could create instruments as powerful as if Earth itself were one vast eye. Through a technique called interferometry, they turned scattered mirrors into a single unified vision, sharpening focus beyond anything possible before. The principle is subtle but profound. 2 telescopes separated by distance can observe the same object simultaneously. By combining the signals and measuring the slight differences in how light waves arrive, astronomers can reconstruct details as if the telescopes were part of one enormous dish stretched across the gap between them. The farther apart the instruments, the sharper the vision. A network of telescopes spread across thousands of kilometers becomes, in effect, a planet-sized eye. This method has birthed some of the most extraordinary instruments on Earth. The Very Large Array in New Mexico, a field of 27 giant dishes arranged in a Y shape across the desert, can move its antennas along railroad tracks, stretching or condensing its reach. From afar, it looks like science fiction, a silent army of white dishes tilting in unison toward the heavens. In reality, it has mapped radio galaxies, traced interstellar clouds, and revealed details of black hole jets with exquisite precision. Even more ambitious is the Atacama Large Millimeter Array, ALMA in Chile, perched high in the thin, dry air of the Atacama Desert. Its 66 antennas work together to capture faint radio waves from the coldest, most hidden parts of the universe. With ALMA, astronomers peer into the birthplaces of planets, watching disks of dust and gas swirl around young stars. They measure molecules in distant galaxies, tracing the chemistry of life across cosmic time. ALMA has shown that the universe is not only vast but molecular, alive with complex structures invisible in any other wavelength. But the most dramatic demonstration of collaboration came in 2019, when the Event Horizon Telescope, a global network of radio observatories linked across continents, produced the first direct image of a black hole. The object lay in the heart of galaxy M87, 55 million light-years away. For decades, black holes had been theory, their presence inferred by the motions of stars and gas. But here, at last, was the image. A dark shadow surrounded by a glowing ring of light, space itself bent by gravity so extreme that not even light could escape. It was not just an observation but a triumph of imagination, engineering and unity. To see the unseeable required turning Earth itself into a telescope. These collaborations highlight something deeper than technology. They show that astronomy is no longer the work of lone observers at isolated instruments. It is the work of nations, institutions, and people across the world, linked by a common desire to see beyond horizons. Each telescope is a piece of a puzzle, each observatory a note in a symphony, each collaboration proof that the universe is too vast for any one eye to capture alone. The metaphor is as striking as the science. Just as no single telescope can see everything, no single perspective can capture truth in isolation. It is only by linking together, sharing data, combining signals, uniting efforts, that clarity emerges. The universe demands collaboration. In this way, telescopes are mirrors not only of the cosmos, but of humanity itself. As networks grow, the dream expands. Future collaborations may link ground-based giants with space telescopes, weaving Earth and orbit into one seamless eye. Adaptive optics, interferometry, radio arrays, and optical networks all point toward the same destiny: to see with clarity as wide as the planet, as deep as time, as sharp as physics will allow. In deserts, on mountaintops, across continents, these telescopes turn together, their signals flowing through fiber cables and satellites uniting into a single vision. They remind us that the cosmos is too grand for solitude. To look outward, we must work together. And in that unity we build eyes not of glass or metal alone, but of humanity's shared curiosity. When humanity first pointed lenses and mirrors toward the stars, the night sky transformed from a stage of mystery into a laboratory of life and death. The twinkling lights overhead were no longer eternal fires. Telescopes revealed them as living entities with beginnings, middles, and ends. Every star is born, every star evolves, and every star dies, leaving behind remnants that shape the universe itself. Telescopes became not just eyes but storytellers, narrating the epic cycle of stellar existence. The story begins in clouds. Through the naked eye, a nebula is a faint smear of light, delicate and mysterious. But telescopes pierce the haze, showing great structures of dust and gas sprawling across light years. In these dark wombs, gravity pulls particles together, dense knots forming within the clouds. Infrared telescopes see through the dust, revealing young stars hidden within, glowing faintly as fusion ignites in their cores. Each one is a sun in waiting, a beacon that will shine for millions or billions of years. The Orion Nebula became one of the first cosmic nurseries to be studied in detail. Telescopes showed it not as a smudge but as a vast star-forming region, where hundreds of newborn suns burn in a cradle of glowing gas. The Hubble Space Telescope captured protoplanetary disks around these stars, swirling rings of dust that could one day become planets. For the first time, we saw creation not as myth, but as process, stars being born before our eyes, planets coalescing in their wake. As telescopes revealed stellar birth, they also showed stellar death. The Crab Nebula, a faint patch of light visible in Taurus, became a revelation when studied through telescopes. In 1054, Chinese astronomers recorded a guest star bright enough to be seen in daylight. Centuries later, telescopes revealed its remnant, a cloud of filaments expanding outward, glowing with energy from a central pulsar. It was the corpse of a star that had exploded, a supernova scattering its guts into space. The nebula's delicate tendrils are fragments of an ancient sun, still racing outward nearly 1,000 years later. Supernovae are not mere explosions. They are the universe's recyclers. Telescopes showed that in their fiery death, stars forge heavy elements, carbon, oxygen, iron, gold, and scatter them into space. Every atom of calcium in our bones, every atom of iron in our blood, was born in a dying star. To study supernovae through telescopes is to study our own origin, to realize that we are children of stellar death. The cycle does not end there. Some stars collapse into white dwarfs, faint embers cooling slowly across cosmic ages. Telescopes revealed them as dense remnants, Earth-sized yet containing masses like the Sun. Others collapse further into neutron stars, dense spheres where matter is crushed to extremes, spinning rapidly, beaming signals across the universe. Telescopes discovered pulsars, these cosmic lighthouses, as regular beacons flashing with perfect precision, and in some cases stars collapse entirely, forming black holes. Here telescopes revealed the ultimate mystery, regions of space where gravity is so strong that even light cannot escape. By observing these stages, birth, life, death, telescopes connected the dots. They showed that the universe is not static but dynamic, an ecosystem where stars seed galaxies with elements, where galaxies recycle material into new stars, where planets arise from dust, where life itself emerges from stellar ashes. What seemed eternal became cyclical. What seemed unchanging became evolutionary. Telescopes also revealed variety. Not all stars lived the same lives. Some, like our Sun, burned steadily for billions of years before becoming red giants and fading into white dwarfs. Others, many times larger, lived brief, violent lives, burning furiously before exploding in supernovae. Still others form in binaries, pairs orbiting each other, exchanging material in cosmic dances that produce novae, X-ray binaries, and other exotic phenomena. Telescopes turn the night sky from a uniform canvas into a tapestry of unique stories, each star carrying its own destiny. Perhaps the most profound discovery came when telescopes measured the light of distant stars and galaxies, splitting it into spectra. From these faint rainbows, astronomers read chemical fingerprints: hydrogen, helium, carbon, oxygen, and more. With each observation, it became clear. The same elements found in stars are found in us. Telescopes did not just show us where stars are born and die. They showed us that we are their children. The light gathered by mirrors and sensors carried a truth that poetry had long intuited. We are made of stardust. This cycle, birth, life, death, rebirth, became the central story of modern astronomy. Through telescopes, the cosmos was revealed not as distant and alien, but as kin. Every atom in our bodies was once part of a nebula, part of a star, part of an explosion. To look through a telescope is to look backward into our own ancestry, to witness the great family of matter and energy to which we belong. Telescopes gave us more than knowledge, they gave us identity. They reminded us that the night sky is not something above us but something within us, written into every molecule of our being. If telescopes revealed that stars live and die, they also showed us that the universe itself is alive with discoveries far stranger than anyone had imagined. From hidden planets orbiting distant suns, to invisible monsters lurking at galactic centers, to the very expansion of space itself, telescopes have given us truths that once belonged only to myth. The search for other worlds began with a question older than astronomy itself. Are we alone? For centuries, telescopes showed only the planets of our solar system, and even these revealed mysteries: polar caps on Mars, swirling storms on Jupiter, hazy clouds on Venus. But beyond them, the stars were thought to be suns too distant for their own planets to be seen. That changed in the late 20th century, when telescopes became precise enough to detect tiny wobbles in stars caused by the pull of orbiting planets. In 1995, astronomers announced the first confirmed exoplanet, 51 Pegasi b, a giant world circling its star every 4 days. Since then, telescopes on Earth and in space have discovered thousands more. Some are gas giants skimming close to their suns, others are rocky worlds in temperate zones, some with hints of water vapour in their atmospheres. Space telescopes like Kepler and TS widened the search, scanning patches of sky and watching for the faint dimming of starlight as planets crossed in front. Each dip was a whisper of another world. The dream of other Earths, once fantasy, became catalogued data. For the first time in history, humanity knew that planets are not rare but common, scattered across the galaxy in unimaginable numbers. Telescopes also revealed monsters once thought invisible. At the heart of nearly every galaxy lies a black hole, millions or billions of times more massive than the Sun. They cannot be seen directly, but telescopes detect their presence in the motions of stars, in jets of energy blasting across light years, in X-rays from matter spiralling into their depths. The Milky Way itself harbours such a beast, Sagittarius a star, a supermassive black hole 4 million times the mass of the Sun. Through decades of observation, telescopes tracked stars whipping around it at dizzying speeds, proving its existence beyond doubt. In 2022, the Event Horizon Telescope gave us the first direct image, a shadow surrounded by glowing light, space itself warped by gravity. It was proof that Einstein's wildest predictions were true, captured not by imagination, but by instruments. And then there is the greatest discovery of all. The universe itself is expanding. In the early 20th century, Edwin Hubble used the Mount Wilson Observatory's giant Hooker telescope to study distant galaxies. He measured their light, stretched into redder wavelengths by their motion. What he found was astonishing. Every galaxy was racing away from us. The farther they were, the faster they fled. The universe was not static but stretching, space itself expanding. This discovery reshaped cosmology, leading to the Big Bang theory, the idea that the cosmos began in a single moment of creation and has been growing ever since. Telescopes have since confirmed this expansion with ever greater precision. They measured the faint afterglow of the Big Bang, the cosmic microwave background, a whisper of ancient light filling the universe. They traced the acceleration of expansion, revealing the mysterious presence of dark energy, a force that pushes galaxies apart faster and faster. Through telescopes, the universe revealed that it is not only vast but restless, not only ancient but evolving. Each of these discoveries, exoplanets, black holes, expansion, carries profound implications. They show us that our solar system is not unique, that our galaxy is ruled by an invisible giant, that the universe itself is dynamic and growing. They remind us that the cosmos is stranger than myth, more wondrous than imagination, more real than dream. But perhaps the deepest truth is not the discoveries themselves, but the fact that we can make them. With mirrors and lenses, with sensors and arrays, with patience and vision, humanity has reached across space and time to touch realities billions of light years away. Telescopes turned night skies into maps, myths into measurements, and mysteries into knowledge. They revealed that the story of the universe is not fixed but unfolding, and that we are capable of reading it. In every exoplanet found, every black hole imaged, every galaxy measured, telescopes whisper the same truth. The universe is knowable, and in knowing it, we come to know ourselves. Telescopes are machines of glass and metal, but their impact reaches far beyond science. They have changed not only what we know about the universe, but also how we see ourselves. Every new lens, every larger mirror, every deeper image has been a mirror for humanity's imagination. Telescopes are not just instruments of discovery, they are instruments of meaning. When Galileo sketched the craters of the moon, he did more than reveal geography. He shattered the idea that the heavens were perfect. Suddenly, the divine spheres above were as rugged and flawed as Earth itself. This was not only a scientific revolution, it was a cultural one. Philosophy, religion, and art all trembled before the new vision. Telescopes forced humanity to reconsider its place, to admit that we were not the centre of the universe but part of a larger, humbler story. That humbling has repeated with every generation of telescopes. When Hubble showed us that the Milky Way is not the entire universe, but one of billions of galaxies, humanity's scale shrank again. When radio telescopes revealed quasars and pulsars, we learned that the cosmos was more violent and strange than our myths had imagined. When the Event Horizon Telescope showed a black hole's shadow, we glimpsed the raw power of gravity bending reality itself. Each time, the telescope spoke not just to scientists but to philosophers, poets, and ordinary people who looked up and asked, "What does this mean for us?" Telescopes also connect us emotionally. To see Saturn's rings through an eyepiece is to feel awe that transcends explanation. To look at the Andromeda Galaxy and realize that every faint smudge is billions of stars is to feel both small and infinite at once. Amateur astronomers, peering through backyard instruments, experience the same wonder as professionals at giant observatories. The connection is not only intellectual, it is visceral, a reminder that the universe is not abstract but real, reachable through light. Culturally, telescopes have inspired art and imagination. Writers turned cosmic discoveries into stories of space travel and alien worlds. Painters captured nebulae and galaxies, blending science and beauty. Musicians composed symphonies inspired by the rhythms of the cosmos. Telescopes made the universe visible, and in doing so they expanded the boundaries of creativity. Every image of the sky became not only data, but also inspiration. Philosophically, telescopes challenge the boundary between seeing and knowing. The eye is powerful, but it is also limited. Telescopes remind us that reality extends beyond our senses, that truth often hides where we cannot look unaided. They teach humility, the lesson that our perception is not the measure of the universe, but only a starting point. This humility becomes a kind of spirituality, a recognition that we are part of something vast, mysterious, and interconnected. The human connection with telescopes is also about time. To look through one is to look back, to see light that has travelled for thousands, millions, or billions of years. A glimpse of a galaxy is a glimpse of the distant past. Telescopes make history visible, showing us not only where we are, but when we are. They bind us to cosmic time, stretching our imagination far beyond human lifespans. And finally, telescopes remind us of unity. The sky belongs to no nation, no language, no creed. When Hubble released its first deep-field image, people around the world felt the same awe, regardless of culture. Telescopes are democratic in their meaning. Anyone can look at their images and feel wonder. They connect us not only to the cosmos, but to each other, through a shared sense of curiosity and awe. Telescopes are thus more than tools of science. They are bridges, between past and future, between Earth and cosmos, between human imagination and universal truth. Every time we lift our eyes through them, we rediscover not only the universe but ourselves. Telescopes have never been only about astronomy. They are woven into the deeper fabric of human meaning. Every image they deliver, every discovery they unveil, becomes part of our cultural memory. We do not simply catalogue these visions, we internalise them, turning data into symbols, numbers into poetry, photons into purpose. When the Hubble Deep Field was first released in 1995, astronomers expected to see perhaps a few faint smudges. Instead, in that tiny patch of sky no bigger than a grain of sand held at arm's length, Hubble revealed thousands of galaxies. The world was stunned. People who had never looked through a telescope felt as though they had glimpsed infinity. For artists, it became proof that the universe itself was a canvas. For philosophers, it was an invitation to humility. For ordinary people, it was a reminder that even in apparent emptiness, abundance waits. Such moments ripple through human imagination. The black hole image in 2019 became an instant cultural icon, appearing on magazine covers, murals, and even tattoos. It was not simply a scientific result, it was a symbol of our ability to make the invisible visible. The photograph represented humanity's reach into the unseeable, a collective triumph of curiosity. Telescopes do not just show us the universe, they show us our own capacity to discover. Art and literature thrive on these revelations. Poets write of nebulae as wombs of stars. Painters recreate galaxies in swirling colours. Musicians compose pieces inspired by pulsars' rhythms, or cosmic microwave background hums. Telescopes feed imagination with images that are both real and surreal, as strange as dreams yet grounded in truth. They remind us that science and art are not separate domains, but complementary expressions of wonder. Philosophy, too, bends beneath the weight of telescopic vision. For millennia, thinkers argued about the cosmos from armchairs, guided by logic, faith, or intuition. But telescopes made speculation testable. They replaced metaphors with measurements, replacing certainty with curiosity. The Copernican revolution, sparked by telescopic evidence, forced philosophy to reframe humanity's place in the cosmos. No longer the centre, we became wanderers on a small planet orbiting an ordinary star in an ordinary galaxy. That shift was not merely scientific, it was existential. Even religion has been reshaped by telescopic vision. For some, the vastness revealed through these instruments is proof of divinity's grandeur, a stage too immense to be accidental. For others, it is a call to rethink sacred stories in light of infinite galaxies. Whether affirming or questioning, telescopes have become part of the dialogue between faith and knowledge, mystery and revelation. But the connection is not only in ideas, it is also deeply personal. Ask anyone who has looked through a telescope at Saturn's rings for the first time, and they will describe awe, disbelief, joy. That view, so crisp and surreal, feels almost like fiction until the eye confirms it. Children in backyards, students on field trips, hobbyists with small refractors, all experience the same thrill as Galileo did centuries ago. Telescopes democratize wonder. They give ordinary people access to the extraordinary. The human bond with telescopes also lies in their ability to collapse distance. When we look at Andromeda through a telescope, we are seeing light that began its journey 2.5 million years ago, before humans even existed. That photon travelled across emptiness only to end in our eyes. This simple fact binds us to cosmic time in ways no philosophy can. Telescopes remind us that our present is woven into the past, that every glance is an act of communion with history. In collective terms, telescopes build shared identity. Nations take pride in hosting great observatories, in launching space telescopes, in contributing to global networks. These achievements become part of cultural heritage. Just as the pyramids or cathedrals reflected human aspiration in earlier ages, telescopes reflect it now. They are monuments not of stone but of sight, testaments to a species that refuses to stop asking what lies beyond. And perhaps most importantly, telescopes remind us of fragility. In 1990, Hubble's image of Earth from orbit showed a small blue sphere floating in darkness. Later, other space telescopes reinforced this perspective. Earth, so vivid from the ground, is but a fragile dot in cosmic vastness. Telescopes turn our gaze not only outward but inward, forcing us to recognize that the world we inhabit is rare, delicate, and worth protecting. Thus, the human connection with telescopes is complete. They reshape philosophy, inspire art, influence faith, fuel imagination, and bind us to each other. They are not only cosmic eyes, but cultural mirrors, reflecting back what it means to be human in a universe too vast to comprehend yet too beautiful to ignore. Every telescope built so far has carried a simple truth. It will one day be surpassed. Each lens, each mirror, each dome was once the cutting edge, only to become the stepping stone for what followed. The history of telescopes is not a story of final answers, but of continual progress, each generation reaching farther than the last. Today, as we admire Hubble's iconic images and Webb's dazzling infrared visions, astronomers are already planning the next great eyes of humanity, machines so ambitious they make even Webb look modest. The most immediate future lies in the enormous ground-based telescopes now under construction. On the high desert of Chile, the extremely large telescope, ELT, rises like a giant mechanical mountain. With a primary mirror 39 meters across, nearly 4 times larger than any currently in use, it will gather more light than all the world's existing large telescopes combined. Its segmented surface, nearly 800 pieces of polished glass, will work in harmony, adjusted by thousands of actuators that keep the surface perfect to within nanometers. When completed, it will be able to directly image Earth-like planets around other stars, study the atmospheres of distant worlds for signs of life, and probe the nature of dark matter and dark energy with unprecedented precision. Nearby, in the same Atacama Desert, another behemoth is rising, the Giant Magellan Telescope, GMT. Its design is elegant. 7 massive mirrors arranged like petals, each 8.4 meters wide, working together to form an aperture equivalent to 24.5 meters. Each of those mirrors is itself one of the largest single pieces of glass ever cast, polished to a smoothness so precise that if it were scaled to the size of Earth, no mountain would rise higher than a few centimeters. GMT will be able to see details 10 times sharper than Hubble, revealing galaxies, star clusters, and planetary systems with extraordinary clarity. And then there is the 30-meter telescope, TMT, planned for Hawaii or an alternate site, another segmented giant designed to push ground-based astronomy into new realms. Together, these 3 titans, the ELT, GMT, and TMT, represent humanity's greatest effort to anchor cosmic eyes to Earth. They are not isolated projects but global collaborations, involving countries from every continent, their funding and expertise pooled to create instruments no single nation could achieve alone, In space too, the future is unfolding. Webb will not stand alone for long. NASA and its partners envision missions like the Nancy Grace Roman Space Telescope, designed to study dark energy, dark matter, and exoplanets with wide-field vision. Roman will act as a surveyor, mapping vast swathes of the sky with clarity, complementing Webb's deep, narrow focus. Together, they will form a partnership, one casting the net wide, the other peering deep. Beyond Roman, plans are already forming for the Habitable Worlds Observatory, HWO, a mission explicitly designed to search for life. Its instruments will be sensitive enough to directly image Earth-like planets around nearby stars, analyzing their atmospheres for water, oxygen, and chemical signatures of biology. For the first time, a telescope's central purpose will not simply be to look outward, but to answer the question of whether we are alone. It will be humanity's most direct attempt to find kin in the cosmos. Other concepts push the imagination even further. Ideas circulate for massive interferometers in space, fleets of telescopes flying in formation, their signals combined into a single image of staggering resolution. Some envision telescopes parked on the far side of the moon, shielded from Earth's noise, peering into the quiet of the universe. Others dream of gravitational lensing missions where telescopes align with stars to use their gravity as natural magnifiers, turning suns into cosmic lenses. Each of these projects reflects the same hunger, to see farther, sharper, deeper, to look not only at galaxies billions of light years away, but also at planets only light years from Earth, where the signs of life might glow faintly in starlight, to measure the nature of dark matter, the mysterious scaffolding of the universe, to trace the first moments after the Big Bang, to bring the unseeable into sight. But the future of telescopes is not only technical, it is philosophical. As instruments grow larger, so do the collaborations behind them. Nations must cooperate, share costs, share data. The universe becomes not the property of one culture or one people, but a shared inheritance. Telescopes remind us that to look outward requires us to work together inward. The future of cosmic eyes will be not only in their mirrors and sensors, but in our ability to collaborate as a species. Every telescope is a promise, and the promises of the next generation are extraordinary. They will not only refine what we know, they will likely surprise us with what we do not expect. History teaches us that each leap in vision reveals the unforeseen. Galileo did not expect to find moons orbiting Jupiter. Hubble did not expect to show a universe filled with galaxies. Webb is already rewriting theories of the early cosmos. So too will ELT, GMT, Roman, and their successors. The most thrilling part of the future is not what we anticipate, but what will astonish us. The telescopes of tomorrow will be bigger, sharper, more ambitious, but their essence will remain the same. Glass and mirror, metal and sensor turned skyward in defiance of ignorance. They will be the next windows through which humanity gazes outward and inward, discovering again and again that to see the universe is to see ourselves. The telescopes of tomorrow are not only machines of science, they are symbols of longing. Each new mirror, each new array, is an expression of humanity's restless desire to look beyond itself. At their heart, telescopes are acts of faith. Faith that the universe holds meaning. Faith that it is worth seeing. Faith that vision itself is a path to truth. As we look ahead, the future of telescopes is not simply about what we will find, but about what it means to search. Consider the philosophical weight of the next generation. Instruments like the Habitable Worlds Observatory will aim not just to map stars or galaxies, but to ask whether life exists elsewhere. For millennia, humanity has looked to the heavens and wondered if we are alone. With these telescopes, that question may shift from speculation to observation. A faint chemical signature in an exoplanet's atmosphere, oxygen, methane, water, could become the first evidence that another world breathes. Such a discovery would not only reshape science, it would reshape philosophy, religion, and culture. Telescopes may be the instruments that deliver the most profound answer in human history. Even if life remains elusive, telescopes will continue to challenge our assumptions. Each time we build a bigger eye, the universe surprises us. Webb revealed galaxies in the early universe brighter and more structured than theory had predicted. Future telescopes will bring more such shocks, forcing us to rewrite the story again and again. In this way, telescopes remind us that knowledge is provisional, that certainty is temporary, that humility is the only constant. Yet the future of telescopes is not only about discovery but also about identity. These instruments are humanity's collective mirrors. To gaze outward is to gaze inward, to see our place not as central, but as part of something vast. Telescopes stretch the boundaries of perspective, teaching us that we are small, fragile, and fleeting, and yet capable of building machines that grasp light billions of years old. That paradox of smallness and greatness together is the essence of what it means to be human. The cultural impact of future telescopes will be immense. Their images will not stay confined to scientific journals. They will appear in classrooms, museums, music videos, art galleries. They will shape how new generations imagine the universe. Just as Hubble's pillars of creation inspired awe in millions who never studied astronomy, so too will the images from ELT, Roman, and HWO ripple outward into imagination. Telescopes give us not just data, but icons, symbols of wonder that bind humanity across language and culture. Philosophically, telescopes embody our eternal tension between the finite and the infinite. Each one is finite, a mirror with an edge, a machine with a lifespan, a mission with a budget, and yet each reaches for the infinite. Each points to horizons without end, to questions that stretch beyond human lifetimes. They are reminders that even as individuals pass, as civilizations rise and fall, the search continues. Telescopes are humanity's way of writing continuity into the cosmos, of saying, we were here, we looked, we tried to understand. There is also the question of silence. As telescopes become more powerful, they may reveal more of the unknown, and perhaps more of the uninhabited. What if no signs of life appear? What if the cosmos is vast but empty, luminous but silent? In that case, telescopes will have given us another kind of truth, that life on Earth is rarer and more precious than we ever imagined. The absence of voices in the universe would not diminish telescopes' value. It would magnify the urgency of caring for the fragile oasis we call home. The future of telescopes is also tied to collaboration. These instruments are too vast, too expensive, too complex for any one nation. They are global projects demanding cooperation across borders. In this sense, telescopes may become symbols not only of cosmic vision, but of earthly unity. To build them, humanity must work together. To use them, we must share knowledge. They are monuments to what we can achieve not in isolation but in collaboration. In the end, telescopes are not about glass, mirrors, or detectors. They are about vision. Vision not only in the physical sense but in the spiritual and cultural sense. They represent the best of humanity. Curiosity, imagination, persistence. They are our cosmic eyes, but they are also our cosmic mirrors. They show us what lies beyond, but also who we are within. The calm cosmos waits, infinite and patient. With each new telescope we step closer to it, not to conquer, but to connect. The future of cosmic eyes is not a destination but a journey, an eternal search that will never end, because the act of searching is itself the point. To look outward is to live fully, to honour the mystery, to embrace wonder. Long before telescopes, the sky belonged to myth. Constellations were gods, heroes, animals, and stories painted across the darkness. The cosmos was a canvas for imagination, and its patterns gave meaning to human lives. When the first telescopes appeared, they did not end imagination, they expanded it. They replaced symbolic heavens with physical realities, and in doing so they gave birth to dreams more astonishing than any myth. Galileo's crude telescope, aimed at the moon, revealed mountains and valleys. Suddenly the moon was not a goddess or a lantern, but a world. This transformation rippled through imagination. Poets wrote of other landscapes, philosophers speculated on inhabitants, and ordinary people dreamed of walking upon that distant surface. Telescopes turned the impossible into the plausible. What had been myth became geography, waiting to be explored. The discovery of Jupiter's moons was just as transformative. If Jupiter had satellites, might not other planets host their own? Could they be homes for alien life? Telescopes opened imagination outward, making other worlds seem real, reachable, populated not by gods but perhaps by neighbours. Writers like Johannes Kepler imagined lunar voyages. Later, Jules Verne and H. G. Wells spun tales of travel to Mars and beyond. Science fiction was born from telescopic vision, blending data with dream. As telescopes grew, they showed the Milky Way not as a band of light, but as countless stars. Later, they revealed galaxies beyond our own, stretching into infinity. Imagination reeled. Myths of creation were replaced with visions of vast universes, multitudes of worlds, unending horizons. Telescopes did not diminish mystery. They multiplied it. Each discovery opened not closure but wonder, fueling stories, art, and philosophy. In the 20th century, as radio telescopes listened to the sky, imagination shifted again. Signals from pulsars seemed at first like messages, nicknamed LGM, Little Green Men. Though natural, they inspired both caution and hope. Could telescopes one day detect not only stars but civilizations? The idea of listening for alien voices entered culture, from science fiction to serious projects like SETI. Telescopes became instruments not only of astronomy, but of yearning, tuned to the possibility that we are not alone. Images, too, became catalysts for imagination. The Hubble Space Telescope's deep fields revealed galaxies stretching back to near the dawn of time. For scientists, they were data. For humanity, they were visions of infinity, stirring questions about beginnings and endings, purpose and destiny. Children stared at posters of nebulae and galaxies, dreaming of being astronauts or astronomers. Telescopes turned classrooms into portals, imagination into aspiration. Culturally, telescopes became symbols of perspective. They reminded us of scale, that Earth is small, that humanity is fragile, that the cosmos is vast beyond reckoning. This realization seeped into philosophy, literature, art. It challenged anthropocentrism, forcing us to imagine ourselves as part of something larger. The telescope was not just a machine for looking, it was a machine for humbling, for expanding the boundaries of thought. Even today, every new telescope image sparks imagination. Webb's portraits of early galaxies inspire visions of cosmic dawn, of stars forming in the universe's youth. Alma's images of protoplanetary disks spark dreams of other Earths in the making. The Event Horizon, telescope's black hole shadow, conjures visions of space-time itself bending and breaking. These are not merely pictures, they are invitations. They call us to imagine futures, to invent stories, to dream beyond what is known. The relationship between telescopes and imagination is reciprocal. Imagination fuels telescopes. Telescopes fuel imagination. Science fiction inspires scientists, who then build the instruments that make yesterday's fiction today's fact. Writers dreamed of lunar voyages before rockets existed. Telescopes confirmed other worlds, and rockets followed. This cycle continues. The images we see today will inspire the missions we build tomorrow. In this way, telescopes are not only eyes, but muses. They speak not only in data, but in dreams. They expand not only knowledge, but imagination, reminding us that the cosmos is not just to be measured, but to be imagined. Imagination has always walked hand in hand with telescopes, and in the modern age that partnership has only deepened. With each new discovery, our stories expand, our art transforms, and our sense of what is possible evolves. Telescopes not only sharpen our sight, they ignite our dreams. Perhaps nowhere is this clearer than in the search for extraterrestrial intelligence. When radio telescopes tuned to the cosmos in the mid-20th century, some astronomers dared to imagine that faint signals might carry voices, not noise. The SETI project, Search for Extraterrestrial Intelligence, emerged from this daring hope. Telescopes scanned the sky for patterns in radio waves, whispers of civilizations perhaps older and wiser than our own, though no. Confirmed signals have been found, the effort itself is an act of imagination. It says, we believe the universe may be alive with others. It asks, are we prepared to meet them? SETI's cultural impact has been immense. Films like Contact and novels by Carl Sagan and Arthur C. Clarke wove the idea into public consciousness. Radio dishes like Arecibo became icons not just of astronomy, but of possibility. Even silence, decades without a confirmed message, feeds imagination. Perhaps civilizations are rare. Perhaps they hide. Perhaps they are waiting. Telescopes do not answer these questions, they keep them alive. Artificial intelligence now joins this imaginative dialogue. Modern telescopes produce torrents of data, too vast for humans to analyze alone. AI sifts through signals, images, and spectra, searching for patterns invisible to us. In doing so, it becomes both tool and muse. What if an algorithm detects a subtle anomaly, a hint of something artificial in the noise? Would it be science fiction turning real? The idea itself, whispered across labs and conferences, fuels dreams of discovery. Telescopes, amplified by AI, become not just eyes but minds, extensions of human imagination into machine creativity. Virtual telescopes expand the metaphor further. Today, vast networks of telescopes link across Earth and space, their data streamed online, accessible to anyone with curiosity. A child with an internet connection can look through the same instruments that professionals use, watching galaxies come into view on their screen. In this democratization of vision lies another dream, that the cosmos belongs to all of us, not only scientists. The telescope becomes a shared imagination, a collective portal to wonder. Culturally, telescopes remain catalysts for creativity. Artists reinterpret their images in painting, sculpture, and digital media. Musicians compose soundscapes based on pulsar rhythms and planetary oscillations. Writers craft stories of future telescopes that see not only across space but across time, peering into parallel universes or simulating cosmic origins. Each act of imagination is a dialogue with the visions telescopes provide. But perhaps the deepest connection is existential. Telescopes reveal our smallness, a pale blue dot orbiting a middling star in a spiral arm of a galaxy among trillions. Yet they also reveal our greatness, creatures capable of building instruments that reach across billions of light years. This paradox, our insignificance and our significance together, is the fertile ground where imagination blooms. Telescopes show us that we are not the centre, but they also show us that we can comprehend the whole. Imagination stretches toward futures still unwritten. What will the next telescopes reveal? Worlds like Earth, their skies blue and their seas alive, signs of civilizations encoded in starlight, or will they confirm a silence so deep that life itself becomes a miracle unique to Earth? In each case, imagination prepares us. We tell stories of first contact, of cosmic loneliness, of journeys to distant suns. We dream before we know, and then telescopes test the dream. The calm cosmos invites this interplay. Its light travels patiently, waiting billions of years to reach us. We receive it not passively but creatively, weaving meaning into photons. Telescopes are the medium, imagination the interpreter. Together, they create a dialogue across time and space. The universe speaks in light, and humanity answers in story. In the end, telescopes do more than reveal what is. They inspire us to imagine what could be. They bridge the known and the unknown, the real and the dreamed. They remind us that science and imagination are not rivals but partners, each feeding the other in an endless cycle of wonder. And so, the human imagination of the cosmos continues, fueled by every new eye we build, every new image we receive. The universe may be infinite, but so is our capacity to dream. Telescopes began as fragile tubes of wood and glass, yet across 4 centuries they have become symbols of humanity's deepest aspirations. They are not merely tools for observing the stars, they are instruments in a grand symphony, each one adding new notes, each one expanding the melody of discovery. To trace their history is to hear a composition that spans generations, each era contributing its own movement, building toward a harmony that continues even now. The first movement was humble. Galileo's telescope revealed that the moon was scarred, that Jupiter carried companions, that Venus circled the sun. Those discoveries were like the opening notes of a symphony. Simple, startling, setting the theme. Humanity was no longer at the centre. The cosmos was broader, richer, stranger. The harmony of ancient belief gave way to a new cadence of evidence and wonder. The second movement came with the great refractors and reflectors of the 18th and 19th centuries. Their domes rose on mountain tops, their mirrors stretched wide, their images captured on photographic plates. They turned faint smudges into galaxies, mapped nebulae, and revealed the architecture of the Milky Way. These telescopes added depth to the melody, introducing themes of scale and multiplicity. No longer was the universe a simple stage of stars, it was a vast, layered composition. The third movement emerged in the 20th century with radio dishes and detectors of invisible light. The cosmos began to sing in frequencies beyond vision, pulsars ticking like cosmic metronomes, quasars blazing with power, the microwave background humming softly as the echo of creation. This was the orchestra expanding, new instruments joining in, new voices entering the symphony. The universe was no longer silent. It was alive with sound, rhythm, and resonance. The fourth movement soared into space. Hubble's sharp vision and Webb's golden mirrors lifted the melody higher, free from atmospheric distortion. They revealed the deep field of galaxies, the pillars of star formation, the glow of the early universe. With these eyes in orbit, the symphony reached crescendos of clarity and beauty, uniting humanity in awe. These telescopes were not only instruments, they were cultural choruses, their images shared across the world, their music heard in classrooms, homes, and imaginations alike. And now the symphony continues with new instruments tuning. The extremely large telescope, the giant Magellan, the Roman space telescope, all prepare to add new themes. They will search for Earth-like worlds, measure dark energy, glimpse cosmic dawn. Their movements have not yet been played, but anticipation itself is music, the quiet before the next crescendo. What makes this symphony eternal is not that it has an ending, but that it does not. Each telescope adds its voice, then fades, but the composition continues. Galileo's notes still echo in Webb's harmonies. The refractor's themes are woven into Alma's rhythms. The song is cumulative, never silenced, only enriched. Humanity, through telescopes, has become the composer of a melody played on the strings of the cosmos itself. Culturally, this eternal symphony is more than science. It is identity. Telescopes remind us that we are not static but evolving, not isolated but connected, not ignorant but curious. They are instruments of humility, each discovery shrinking our sense of centrality, but also instruments of empowerment, each discovery proving our capacity to understand. The music they create is at once humbling and uplifting, small and vast, finite and infinite. Every time a new telescope opens its eyes, the symphony swells again. Each photon captured is another note, each discovery another chord. The song has no final measure, no last crescendo. It is an eternal composition, and we are both its players and its audience. To be human is to live inside this music, to add our voices of curiosity to its endless refrain. Telescopes are not only machines, they are movements in a timeless symphony, echoes of our desire to see, to know, to belong. Their music stretches from Galileo's sketches to Webb's infrared masterpieces, from backyard amateurs to global arrays. Together they remind us that the universe is not silent. It is a song, and we are part of its eternal harmony. The story of telescopes is not ending, it is becoming infinite. Every new eye we build extends our vision not only outward but inward, shaping how we understand ourselves. They are more than machines of glass, mirror, and metal. They are symbols of persistence, proof that humanity refuses to stop asking questions, refuses to stop listening, refuses to stop looking. Philosophically, telescopes embody the paradox of vision. To see farther is to realize how much remains unseen. Galileo revealed moons, but he could not imagine galaxies. Hubble revealed galaxies, but it could not pierce the universe's earliest moments. Webb now shows us the dawn of galaxies, but it too will leave questions unanswered. Each telescope answers, and each answer breeds more questions. The symphony is eternal because curiosity is eternal. There is also silence in this music. Despite decades of listening, no telescope has confirmed a signal from another intelligence. Despite countless images, we have not yet seen another Earth alive with green continents and blue oceans. This silence is itself a kind of note, reminding us of the rarity and fragility of life on our own planet. Telescopes turn our eyes outward, but their message often points homeward. Earth is precious. Protect it, for it may be unique. And yet, telescopes never despair. Every image of a distant galaxy, every faint exoplanet-like curve, every whisper of radiation is a form of hope. Hope that the universe is knowable. Hope that our species can understand creation itself. Hope that wonder will never run dry. Even if no alien voices answer, Even if the cosmos proves lonely, telescopes assure us that the journey itself has meaning. To look is enough. To search is to live. The cultural legacy of telescopes is therefore not just knowledge but perspective. They collapse distance, binding us to photons born billions of years ago. They collapse time, letting us see the universe as it was before Earth existed. They collapse boundaries, uniting nations in collaboration to build instruments larger than any one country could imagine. They collapse solitude, giving billions of people across the world a shared vision of the same stars, the same galaxies, the same cosmic wonders. And in the end, telescopes remind us of something deeply human, our need for vision. We are creatures who long to see beyond horizons, to push past limits, to turn darkness into light. The calm cosmos stretches endlessly above, and our telescopes are our eternal companions in that journey, eyes we have built to extend our own. This is the eternal symphony, not a final crescendo, not a resolved chord, but an endless rising melody of curiosity. Telescopes are its instruments, and humanity is both composer and audience. The music will continue as long as we continue to look, as long as we continue to ask, as long as we continue to wonder. The calm cosmos waits, infinite and patient, and we, with our cosmic eyes, will keep looking forever.